Hey guys, this is Megan from OnlineMathCircle AIME video tutorials. Today we're going to look at 2007 AIME II, problem number 2. Find the number of ordered triples A, B, C, where A, B, and C are positive integers. A is a factor of B, A is a factor of C, and A plus B plus C is equal to 100. So we see here that A is a factor of B and C. And since A plus B plus C is equal to 100, that means that A can be factored out from the left-hand side, which means that A must be a divisor of 100. So that means A has to equal 1, 2, 4, 5, 10, 20, or 25. However, A cannot equal 50, or else we would have B plus C equal to 50. And if B and C have to be multiples of 50, then that means that forces B or C to be 50 or more, which will result in one of the numbers being equal to 0, which we can't have since A, B, and C are positive integers. So that means A can only be up to 25. So let's look at each of the values of A case by case. So if we look at A equal to 1, that means B plus C is equal to 99. 1 is a factor of every whole number. So that means we can have B all the way up to 98, but at the same time B has to equal 1 at the very least. So that means there are a total of 98 triples when A equals 1. Now let's move to A equal to 2. That means B plus C is equal to 98. So the least that B can and B would be 2. So then that would be like 2 plus 96. And B and C have to be even since 2 is only a factor of even numbers. So that means we can have in order of B and C 2 plus 96, 4 plus 94, 6 plus 92, etc., all the way to 96 plus 2. And that gives us a total value of 48 triples. Now let's move on to A equals to 4. Here we have B plus C equal to 96. The lowest value of B that's possible, such that we can manage to have 4 being a factor of B and C, would be B equal to 4 and C equal to 92. Then we can have A plus 88, etc., all the way to 92 plus 4. This gives us a total of 92 divided by 4, or 23 triples. Now let's move on to A equals 5. If A equals 5, B plus C equals 95. B can be at least 5, which makes C 90 in that case. And then the value of B can just keep going up by 5, etc., all the way to 90. So that gives us a total of 90 divided by 5, which is 18 triples. Now let's move on to A equal to 10. This gives us B plus C equal to 90. So that means B, at the very least, can be 10, which leaves C as equal to 80. Then we can also have 20 plus 70, etc., all the way to 80 plus 10. That gives us 8 triples. Now let's move on to A equal to 20. This means that B plus C is equal to 80. B must be at least 20, which at that at least value gives C as 60. B can also be 40, which leaves C as 40. And it can also be 60, which leaves C at 20. So that gives us 3 triples in this case. Finally, let's look at A equal to 25. This gives B plus C equal to 75. B must be at least 25. So at that value, that gives us C equal to 50. B can also be 50, and C can be 25, the other way around. This gives us 2 triples. So, as asked in the original problem statement, we must find the number of ordered triples, A, B, C. So, we have to take all the values that we obtained from each case, aka each value of A, and then all we have to do is simply add them up. And that adds up to 200 triples total.